All right, y'all. So we started this one in class, but I just wanted to demonstrate the use of Kirchoff's laws. All right, I wanted to make sure that you'd seen it all the way through. So just a chance for you to do this. Now, as I do this, I'm going to make some decisions that you probably are going to think, well, that was a dumb decision. But the whole point is I want you to see that it really doesn't matter. Okay? So here's what I'm going to do. I'm going to start with Kirchoff's first law. Now, Kirchoff's first law, remember, says that at an intersection or junction, the current in and the current out should add up to 0. So positive currents coming in, negative currents going out. Now, in order to do this, we do need to make sure to identify the current in each kind of leg here. So I'm going to have the current going through here. That's going to be current number 1. Now I have that going in the direction of the 6-volt battery, and that should be more or less what I expect to happen there. Now the 2 ohm resistor, I'm just going to go ahead and come through the 2 ohm resistor like that. Okay, I'm going to call that current 2, and actually it shouldn't quite go that far because it only goes up to the junction. So right there. So I've got the first one doing that top piece. Only mark the current in a single wire. So if it splits or if it joins or something like that, you need a new current. And then last of all, from here down around the other way like this, it should go all the way around and then back to where it joins up. That's going to be my current 3. Now, I know that some of you think, but Mr. Bauwater, the 9-volt battery, the current should be going the other way. It really doesn't matter. In fact, I want to show you what happens if I choose the wrong direction. So that's actually the only one I'm 100% sure of should be going the other direction, but it doesn't matter. Now, as I come into a junction here, right? So let's look at the junction at this point. What we have is we have I1 coming in, so I'm going to call that positive. I've got I2 is coming out, so that's going to be a minus I2. And then I've got I3 also coming out, remember, because I'm going the other direction there. So that's also going to be a minus I3. Those all together should be 0. And don't worry about it. If I choose the wrong direction, all that means is that I'm going to end up getting a negative current later. And the negative current will just mean that I chose the wrong direction. All right? So that's it. Now, there is another junction over here. If I have more junctions that will give me more equations, I'm happy to use Kirchoff's first law because it's a little bit simpler. But unfortunately, this point is going to be 2 coming in, 1 going out, 3 coming in. So 2 and 3 are essentially going to be the same, and 1's going to be doing the opposite. So that point doesn't really give me a new equation. It just gives me one that's similar to what I already have. All right? So now what we're going to do is we're going to go ahead and we're going to choose a loop because I have 3 currents, so I have 3 different variables here. Now what that means likely is that I am going to need 3 different equations. All right, so we're going to go ahead and choose another loop. All right, now it doesn't matter what loop you choose. I'm going to choose a different one than what we did in class, so I'm going to go through this loop right here. I'm going to go around just like that. Okay, now if I start here and I go through that 1 ohm resistor, look at the direction that my I1, my current 1, was going. It's going this direction. I'm following that direction right now, which means as I go through the 1 ohm resistor, it's going to be minus IV. So I is I1. Now I find it easiest to put the current, the resistance first, so RV. Remember, this is V equals IR, which is the same as RI. It doesn't matter, but it is going to be negative because I expect to lose potential as I go in the correct direction across that resistor. Okay, then as I go up, I'm going to go over, I'm going to go through the 6 volt. I'm going from the small side to the big side. So as I go from the small side to the big side, I should gain 6 volts. Then I'm going to come down here, down. I'm now going through the 2 ohm resistor. Look at the direction of my current 2. It's going in that direction. So I expect to lose I2, and then the current there is I2, which then should take me all the way back to where I started. So that should equal 0. So now I've got I1, I2, I3 in the top. I've got I1 and I2 here. Now I need one more equation here. I need one more loop. So I could do the one on the bottom, but you know what? I think I would like to do the big loop, okay? So what I'm going to do is I'm going to start at the same point as before, but I'm going to go all the way around the outside like this, okay? Now, so as I go through the 1 ohm resistor, again, I'm going in the direction that I should be. So that's minus 1 I1. That's my IR. Then I'm going to go through the 6V, again, going from the small side to the big side. So that's going to be a plus 6. Then I come over here and I go down, and I'm going all the way around the outside. Now this time I'm going through the 3 ohm resistor, and notice that again I'm going in the direction of the current that I've identified, which means this is going to be another minus 3. This current is going to be I3. And then I'm going through the 9-volt battery. Now if I go through the 9, this time I'm going from the big side, the positive side, to the negative side. So I need to lose 9 volts there. And then I come back all the way around the outside back to where I started. And so at this point, I now have 3 equations with 3 unknowns. Now, the nice thing is your calculator can solve this for you, but you do have to put it in kind of standard form. All right, so standard form is going to be I1, then I2, then I3, and then all the constants on the other side. Okay, so if I put I1, and then a minus I2, and then a minus I3 equals 0. Now I'm going to do the same thing with that second equation there. I'm going to put the I1 first, so that'll be minus 1 I1. I have the minus 2 I2 here, so minus 2 I2. There's no I3, and I'm actually going to take that 6 and move it to the other side, so that'll be equal to a negative 6. Okay, and then the last equation, same thing. I want that minus 1 I1 first. All right. I've got the minus 3 I3 there. There's not an I2 in that purple one. I have a plus 6 and a minus 9, so that'll be a negative 3, which I'm going to add to the other side, so that will be equal to 3. Now at this point, I can put this into the simultaneous equation solver on my calculator. So I'm going to invite you to do that. I'm not going to do the math of that here. This is not meant to be a math video. This is going to be this is just the physics behind it, and you should be able to put that into your solver and solve for I1, I2, and I3. If you have any questions on that, just ask me. I'm happy to help you get through it, okay? Now, in this process, if I get any negative numbers for current, that just means that I chose the wrong direction, so therefore I was adding when I was subtracting. Okay, I do want to do one other thing here, just for the sake of doing it, is I want to show you what it might look like if I choose a different loop that maybe I'm going in the wrong direction as I go through that loop. All right, so hang with me here. I've got enough information I could solve the question now, right? But what if I did a loop here in the bottom? Okay, what if I did this bottom loop here and I went this way and then I went back this way and then back to there? Okay, so let's start right at this point. Okay, so I go through the 2 ohm resistor, and that is the direction of my current, so that'll be minus 2 I2. All right, then I go through here. I'm not passing through anything, so that's all fine. I go through my 9-volt battery. I'm going from the minus to the positive, so that'll be plus 9. Now, look at this. As I go through my 3 ohm resistor, I identified earlier that the direction of I3 was to the right. Now, I am going the wrong direction across the resistor. Now, as I follow the direction of the current, that I3 going to the right, I expect to lose potential difference. Now, if I go the wrong way across the resistor, I should go from a lower resistance up to a higher resistance. And so instead of putting a minus, I'm actually going to put a plus and then 3 and then I3 there. So what that's saying, I understand that I chose this direction to the right as my current, right? That's what I was doing here with my I3. I'm going the wrong way across the resistor. So instead of losing resistance, I'm going to gain resistance. And then from there, I end up going right back to that same point. So that will be equal to 0. And at this point, I should then be able to solve for each of those currents. I should be able to, this could be one of my equations here. Instead of the equations that I have, I could have used this one instead. Now, don't have 4 of them. It's not necessary. But with the 3 that I could have used that one instead of one of the others. My point that I wanted to show you is, well, what if I go the wrong way across a resistor? Well, you go the wrong way across a resistor, you need to add that V equals IR instead of subtracting it. Okay, so hopefully that was helpful. We will look more at Kirchoff's laws in class, but for now, that's a good start.